I'm going to go ahead and give this disclaimer. I do apologize. I will stumble on these words because a lot of them do not work well when you have a lisp. That being said, let us begin. Phobic. Psychologically with humans is a fear on such an elevated level that people will go to any extremes to avoid what they are afraid of or do what they can to prevent it from happening. When it comes to a molecular level, being phobic is similar in the fact that molecules themselves will avoid the molecules that they do not blend well or mix well with. Hydrophobic molecules are simply molecules that avoid water. This is because as a molecule that is a hydrophobic structure makes it incompatible with water, whereas where the molecules, for lack of a better way of saying, do not get along. A prime example is oil and water. When an oil leak happens in the ocean, the water floats and stays on the surface and does not disperse or mix in. Of course, oil is not the only hydrophobic substance, as lipids, which a different kind of oil is a part of, are also majority hydrophobic, except for, and this is one I'm going to stumble on, so I do apologize, phospholipids, which are both hydrophobic, the tails, and hydrophilic, the heads. Hydrophilic is the opposite of hydrophobic, in that these molecules mix well with water on the molecular level. A prime example of something hydrophilic is carbohydrates. These sugars mix well with water and dissolve or absorb water. Prime example of a complex carbohydrate is the potato, which is a starch and absorbs water. This is because the molecules work with each other instead of avoiding each other as with hydrophobic molecules. The structure of the hydrophilic molecule enables the molecule to work alongside or mix and blend with the water molecules, where hydrophobic molecules are just not able to. If we had two beakers and filled them fully with water, it would be a straightforward way of showing the difference between these two. Both filled with water, one having oil placed in it and the other a cube of sugar. As we first watch the beaker with the oil put in the water, we will see the oil staying on top of the beaker and not diluting or disappearing. Next, we return to the beaker with a cube of sugar in it as we watch the sugar slowly dissolve and mix with the water as the molecules will work well together. This is because sugar is soluble in water and will break down and in turn increase the density of the water instead of staying on top and trying to avoid the water like oil, which is insoluble in water.